Chapter 5, Fractions, Decimals, and Percents. (5-1) Determine whether the number 63 is prime or composite. Answer. The number 63 has 6 factors: 1, 3, 7, 9, and 21. Therefore, it is a composite number. A composite number has multiple factors. Determine whether the number 41 is prime or composite. 41 the only factors of 41 are 1 and 41. The number 1 and itself. Therefore, it is prime. If a number can only be divided by 1 and itself, it is prime. If it has multiple factors, it is called composite. Determine whether the number 29 is prime or composite. The number 29 has only 2 factors, 1 and 29. If a number is only divisible by 1 and itself, it is prime. Determine whether the number 24 is prime or composite. Write factors. 24 is divisible by 1, by 2, by 3, by 4, by 6, by 8, and so on. If it's divisible by anything other than 1 and itself, it is composite. It is a composite number. Find the prime factorization of 100. You use a factor tree. Start with the number that they're asking for, 100. Then start dividing it. 100 divided by 2. That's 50 times 2. You're trying to get all prime numbers. 2 is a prime number, so we're carrying it all the way down. That is what this is. An arrow going all the way down. 50 is a composite number, so divide it again. 25 times 2. 2 again is a prime number. We're going to carry that one down. We then have 25. 25 is 5 times 5. 5, 5 are both prime numbers. So at the bottom, we have all prime numbers. That is the prime factorization. All prime numbers of a number. 5, 5, 2, and 2. The second way to do it is to divide by prime numbers. So we have, right here, 100 divided by 2. 2 is a prime number. That gives us 50. Divided by 2 again, that gives us 25. Divided by 5, that gives us 5. We then look at these numbers that we divided by and the last remainder. So the prime factorization of 100 is 2 times 2 times 5 times 5, or 2 squared, there are 2 2's, times 5 squared. If you were to multiply this out, it equals 100. If you were to multiply this out, it would also equal 100. Find the prime factorization of 72. Well, here's the answer, but we can do it the exact same way if we do a factor tree. 72, if we divide it in half, that gives us 2 and 36. 2 is a prime number, so we carry 2 down. 36 divided by 2, 18, 2. Carry this 2 down, as well as this 2. They're both prime numbers. 18 divided by 2, 2, 9. Carry all of the 2's down. 9, you can't divide it by 2, but you can divide it by 3. 9 is 3 times 3. So the prime factorization is 3 times 3 times 2 times 2 times 2. Or 2 to the third power, there are 1, 2, 3 2's, times 3 to the second power, there are 2 3's. Factor 21m squared n. First, separate them. So separate the number from the variables. So we have 21 times m squared n. 21, you can't divide it by 2, but you can divide it by 3. So 3 times 7, m squared n, separate those again. M squared times n. N is the prime factor, is the prime number. There's no other number, n to the 1 prime. M squared can then be factored into m times m. 3 is prime, 7 is prime, m to the 1, m to the 1, and n to the 1. So the prime factorization of 21 m squared n is 3 times 7 times m times m times n. Factor 15x y cubed. We do it the same way. 15 times x y cubed. That then gives us 5 times 3 and x y cubed. 5 is prime, 3 is prime, x to the 1 is prime, y to the 3 becomes y, y, y. So we have 5 times 3 times x to the 1 times y to the 1 times y to the 1 times y to the 1. Here's the answer. That is the end of lesson 5-1. Greatest common factor. Find the greatest common factor, or GCF, of 28 and 42. First, list the factors. So we have 28, 1, 2, 4, 7, 14, 28. 42, 1, 2, 3, 6, 7, 14, 21, 42. You then look for the numbers that both of them have as factors. 1, 2, 7, and 14. The question is for the greatest common factor. Greatest means largest. So it wants to know the largest factor that both numbers have. 1 is the smallest, then 2, then 7, then 14. 14 is the greatest common factor, or the GCF. You can also draw a Venn diagram to check your answer. Put the factors of 28 in this circle, 4 and 28. The factors of 42 in this circle, 3, 6, 21, 42. The factors of both in the overlapping part, 1, 2, 7, 14. The largest number is 14. Find the greatest common factor of 18 and 45. Again, just list the factors. Both are divisible by 1. 18 is divisible by 2, by 3, by 6, and by 9, as well as by itself. 45 is divisible by 3, 9, 15, and 45. Look for the numbers that are the same. 1, 1, 3, 3, 9, 9. That's it. The greatest common factor is 9. The largest number they both have is 9. Find the greatest common factor of 20 and 32. Write the prime factorization. So we have 20 is 2 times 2 times 5. That's the prime factorization. 32, 2 times 2 times 2 times 2 times 2. So the common prime factors are 2 and 2. Method 2, divide by prime numbers. Divide both 20 and 32 by 2. Then divide the quotients by 2. So we have 20 and 32 divided by 2, 10, 16 divided by 2, 5, and 8. So the greatest common factor of 20 and 32 is 2 times 2, or 4. So the greatest common factor of 24 and 36. Well, we can do it either of the two ways we just learned. If we do it the first way, we have 24 and 36. Both are divisible by 1. 24 is divisible by 2, by 3, by 4, by 6, by 8, by 12, and by itself, 24. 36 is divisible by 1, by 2, by 3, by 4, by 6, by 9, by 12, by 18, and by itself, 36. What is the largest number that both have in common? 12. Or we have 24, 36 divided by 2, 12, 18 divided by 2, 6, 6 and 9 divided by 3, 2 and 3. Those are prime numbers. Oh, sorry, I did not mean to delete that. 24, 36, we'll go back to the division way, divided by 2, gives us 12 and 18. Again, divided by 2, that gives us 6 and 9. We want to get prime numbers at the top, divide by 3, 2 and 3. You then multiply these numbers. So 3 times 2 times 2, 6 times 2, 12. The greatest common factor is 12. You can use both ways to find the greatest common factor. Find the greatest common factor of 21, 42, and 63. Well, 21, we have 3 times 7 as the prime factorization. 42, we have 2 times 3 times 7. And 63, we have 3 times 3 times 7. So the common prime factors are 3 times 7. So the greatest common factor is 21, 3 times 7. Find the greatest common factor of 24, 48, and 60. You can write out the prime factorization. The prime factorization of 24. You find each of them. So prime factorization of 24 would give us 12 times 2. 2 is the prime, so we know it's 2 times. 12 is 4 times 3. 3 is prime. 4 is 2 times 2. So it's 2 times 2 times 2 times 3. Now 48 gives us 24 times 2. So you immediately know that it is the same as this times another 2. So 2 times 2 times 2 times 2 times 3. 60. 30 times 2. That is 10 times 3. And 5 times 2. So we have 2 times 2. 2 2s. Times 3 times 5. Which ones do they all have in common? 2 times 2 times 3. 2 times 2 times 3. 2 times 2 times 3. So the greatest common factor is 12. 2 times 2, 4 times 3, 12. Find the greatest common factor of p, 12p squared times 30p cubed. 12p squared is 2 times 2 times 3, p times p. 30p cubed, 2 times 3 times 5, p. The greatest common factor is 2 times 3, p times p. So 6p squared. So 14m squared n, 21 mn cubed. So 14 mn squared would give you 7 times 2 times m times m times n. 21 mn squared, 7 times 3 times m times n times n times n. Look at what they have in common. They both have a 7. So we know the answer will be 7. They each have 1 m. They each have 1 n. So 7 m n. That is the greatest common factor. Example 5. Sierra wants to cut a 15 centimeter by 25 centimeter piece of tag board into squares for an art project. She does not want to waste any of the tag board, and she wants the largest squares possible. What is the length of the side of the square she should use? The largest length of the side board is the greatest common factor of the dimensions of the tag board. So we have 15, 3 times 5, 25, 5 times 5. The greatest common factor of 15 and 25 is 5. Sierra should use squares with sides measuring 5 centimeters. Alice is making candy baskets using chocolate hearts and lollipops. She has 32 chocolate hearts and 48 lollipops. She wants to have an equal number of chocolate hearts and lollipops in each basket. Find the greatest number of chocolate hearts and lollipops Alice can put in each basket. Find the greatest common factors. So we do prime factorization of 32 and 48. 32 becomes so we get 16 times 2. So 16 then becomes 2 times 8. 8 becomes 4 times 2. So we have 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32. 48 we get, we break it down, we have 24 times 2, 12 times 2, 4 times 3, 4 is 2 times 2. So we have 2, 2, 2, and 2. So we have the greatest number of cookies, of chocolate hearts and lollipops Alex can put in each basket is 2 times 2 times 2 times 2, or 2 to the 4th, which is 16. End of lesson 5-2. Fractions in simplest form. Write 12 over 45 in simplest form. First, find the greatest common factor of the numerator and denominator. So the factors of 12 are listed here. The factors of 45 are listed here. The greatest common factor, 3. You then divide the numerator and the denominator by the greatest common factor. So 12 divided by 3, 4. 45 divided by 3, 15. 4 over 15 is the simplest form. Multiply the numerator and denominator of the answer by the greatest common factor. The result should be the original fraction. So 12 over 45, written in simplest form, is 4 over 15. That's true. 4 times 3 is 12. 15 times 3, 45. Write 32 over 40 in simplest form. So what's the greatest common factor? 32 and 40. 32, the greatest common factors are 1, are 1, 2, 4, 8, 16, and 32. 40, we have 1, 2, 4, 8. We also have 5, 8, 9, 10. 20, and 40. So the greatest common factor of both are 8. So 32 divided by 8 over 40 divided by 8. 32 divided by 8, 4. 40 divided by 8, 5. The answer is 4 over 5. Write 40 divided by 64 in simplest form. 40 is 2 times 2 times 2 times 5. 64, 2 times 2 times 2 times 2 times 2 times 2. The greatest common factor is 8. 2 times 2 times 2. You then divide it by the greatest common factor. 40 divided by 8, 64 divided by 8, 5/8. The answer, 40 over 64, written in simplest form, is 5/8. Write 28 over 49 in simplest form. Prime factorization. 28, we have 2 times 14, 7 times 2. 49, we have 7 times 7. So the greatest common factor that we have is 7. 28 divided by 7, 49 divided by 7 equals 4 over 7. 4/7. Two notes from a perfect fifth. Two notes form a perfect fifth if the simplified fraction of the frequencies of the notes equals 3/4. If note D equals 294 Hertz and note G equals 392 Hertz, do they form a perfect fifth? Frequency of note D, 294, over frequency of note G, 392. The slashes mean that part of the numerator and part of the denominator are both divided by the same number. For example, 7 divided by 7. So we have 2 times 3 times 7 times 7. 2 times 2 times 2 times 7 times 7. We cross them out if they are both the same on the top and the bottom. We are then left with 3 over 2 times 2, or 3/4. The fraction of the frequency of the notes D and G is 3 over 4, so the notes do form a perfect fifth. In a bag of 96 marbles, 18 of the marbles are black. Write the fraction of marbles in simplest form. 18 over 96. The factors of 18 are 1, 2, 3, 6, 9, and 18. The factors of 96 are 1, 2, 3, 6, also 4. Continue on to 96. We know that the greatest common factor is 6. So we have 18 divided by 6, 96 divided by 6. 3, 16. End of lesson 5-3. Write 1 over 8 as a decimal. The fraction 1 over 8 indicates 1 divided by 8. Method 1, use paper and pencil. 8 into 1. 8 goes into 1 0 times. 8 goes into 10 1 time with a remainder of 2. Carry the 0. 8 goes into 20 2 times with a remainder of 4. Carry the 0. 8 goes into 40 5 times with a remainder of 0. 0.125. Use the calculator. 1 divided by 8 equals 0.125. Use 2 over 5 as a decimal. Either do it the long way or the short way. 2 divided by 5. 5 goes into 2 0 times. So we then carry the 20. 5 goes into 20 4 times with a remainder of 0. The answer is 0.4. So we can go ahead and find it that way or use a calculator. Write 7 and 3/5 as a decimal. The mixed number of 7 and 3/5 is 7 plus 3/5. So use paper and pencil. 7 over 3/5 equals 7 plus 3/5. 3 over 5 is 0.6. 3 over 5. So we have 7 plus 0.6 as the answer. The other option is use a calculator. 3 divided by 5 plus 7. So first you find the fraction, and then you add it to the whole number, 7.6. Write 3 and 5/8 as a decimal. First, 5 divided by 8. Second, add it to 3. 3 plus 0.625. 5 over 8 equals 0.625. Add the whole number 3, and you get the answer, 3.625. Use paper and pencil for 1 over 11. 11 into 1, you find it, 0.0909. You're always going to have a 1 remainder. It's not evenly divisible, so you then can put a dot, 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 or use a calculator. This line over the top means that it is repeating. Over and over, it will continue in the same manner. 0, 9, 0, 9. On and on. That's what the dot, dot, dot means. You can also put a line over it. It means the same. Write 2 divided by 9 as a decimal. Divide it. Goes in 0 times. Goes in 2 times. Remainder 2. 9, 2. 2. It's going to continue on like this. It will always have a remainder of 2, so we put a line over the top, or over the first one, 0.2. That means that the number will continue on with a 2. Write 6 and 4/9 as a decimal. Remember, first we find the fraction as a decimal. 4 divided by 9, 0.4, continuing. You then add the whole number, 6 plus 6.4, or use a calculator. Find 2 and 5/11 as a decimal. 5 divided by 11. 11 goes into 5. 50, goes into 50 4 times, with the remainder of 6. Then carry a 0 down. 11 goes into 60 5 times, with the remainder of 5. We then see that it's going to be repeating. So it's 0.45, continuing. You then add the whole number, 2. So we have 2 plus 0.45, giving us the answer. Write 0.72 as a fraction in simplest form. 0.72 is 72 over 100. The 2 is in the hundredths place. So we then simplify it. 72 and 100 can each be divided by 4, giving us 18 over 25. Write 0.85 as a fraction in simplest form. 85 over 100. Both can be divided by 5, giving us 17 over 20. It cannot be divided any lower. End of lesson 5-4. write ratios as percent. Write the ratio as a percent. Diana scored 63 goals out of 100 attempts. You can represent 63 out of 100 with a model. Here's the picture. So the answer, 63 over 100, 63%. For percent, that means per 100. So 63 out of 100 is in the form that we need it to be a percent. 63 per 100%. Alicia sold 34 out of 100 cookies at the bake sale. So what is it as a percent? 34%. If it is over 100, out of 100, the number given is the percentage. 31.9 out of 100 people bought crunchy peanut butter. 31.9 over 100 is 31.9%. 73.4 out of 100 people preferred the chicken instead of the roast beef. If it's out of 100, your percentage is the number. 16 over 25 as a percent. Since 100 divided by 25 is 4, you then multiply the top and the bottom by 4 to get it into the percent per 100. 16 times 4 is 64. 25 times 4 is 100. If it's out of 100, you use that number as a percent. Therefore, 64%. 64 out of 100 is 64%. So 16 out of 24 equals 64%. Change this fraction into something over 100. Write 11 over 20 as a percent. Well, 20 times 5 equals 100. So multiply the bottom and the top by 5. You then get 55 over 100. So 11 over 20 as a percent is 55%. Write 22% as a fraction in simplest form. So we know that 22% is saying 22 out of 100. You then simplify. Both numbers can be divided by 2. You then get 11 over 50. That is the simplest form. It cannot go any lower. Write 84% as a fraction in simplest form. 21 over 25. 84 over 100. Both numbers can be divided by 4, giving us 21 over 25. Recreation. The graphic shows the most popular outdoor activities according to parents with children ages 4 to 14. What fraction of parents prefer hiking as a favorite outdoor activity? Well, in the bar graph, 15 parents chose hiking. You then find the total number. 15 plus 33 plus 13 plus 13. 74 total. So 15 out of 74 of the parents chose hiking. Each member of the football team is supposed to get playing time in each game. By the end of the third quarter of the game, 17 out of 25 players had already been in the game. What percent of the players is this? 17 out of 25. Percent is per 100. 25 times what is 100? Times 4. Multiply the top by 4, you get 68. 68% had been in the game. End of lesson 5-5. According to the Administration on Aging, about 28% of the population of the United States is 19 years of age or younger. Write 28% as a decimal. 28 over 100. 28 divided by 100 is 0.28. 28 divided by 100. When you're divided by 100, you know that the decimal point will go at the beginning. 2 places. A popular amusement park reports that 17% of its visitors will return at least 3 times during this year. Write 17% as a decimal. 17 per 100, 0.17. The decimal moves to the beginning of the number. Write 47.8 as a decimal. 47.8 divided by 100, 47.8 times 10 times 10, 478 divided by 1,000, 0.78. Again, when you're dividing by 100, the decimal point just moves to the beginning of the number. So 0.478. Or you can find it in the thousands and move it then to the beginning. Write 83.2% as a decimal. You can either multiply both by 10, giving you 832 out of 1,000, and then do 0.832, or just remember, when you're dividing by 100, the decimal point moves to the beginning of the number, 0.832. Write 95.3 as a decimal. When you divide by 100, move the decimal point 2 places, remove the percent sign, 0.953. Write 38% as a decimal, 0.38. Write 8 1/5% as a decimal. So first, find what 1/5 is as a decimal. 1/5 is 0.2. So 8 1/5% equals 8.2%. Move the decimal point 2 spaces. That gives us 0.082. Write 27 3/4 as a decimal. First, find what 3/4 is. That's 27.75% over 100. Move it 2 spaces. 0.2775. In 1790, about 1/5 of the population of the United States lived in an urban setting. Write 0.5 as a percent. 0.05 is 5 out of 100. 5%. So 0.05 is 5%. In 2000, the population of Illinois had increased by 0.086 from 1990. Write 0.086 as a percent. If you're going to divide it by 100, you're moving the decimal point 2 spaces and adding a percent sign. 8.6%. Write 0.121 as a percent. 0.121 is 121 over 1,000, or 12.1 over 100, 12.1%. Write 0.364 as a percent. 364 over 1,000, 36.4 over 100, 36.4%. Write 0.33 as a percent. 0.33, move the decimal place 2 places, you add a percent sign, 33%. Write 0.52 as a percent. 0.52, Move the decimal place 2 places, add a percent sign, 52%. Right? 0.419, add a percent, move the decimal place 2 places, add a percent, 41.9. Right? 0.869, add a percent, move the decimal place 2 places, add a percent sign, 86.9%. End of lesson 5-6. Find the least common multiple by listing multiples. So find the least common multiple, LCM. First, list the multiples of 4 and 6. 4, 8, 12, 16, 20, 24, 28, 32, 36, ... 6, 12, 18, 24, 30, 36. Notice that 12, 24, continuing on, 36, are common multiples. The least common multiple of 4 and 6 is 12. The smallest number that both are multiplied into. Find the least common multiple of 8 and 12. 8 times 1 is 8, times 2 is 16, times 3 is 24, times 4, 32, times 5, 40. 12 times 1, 12, times 2, 24, times 3, 36. Oh wait, it asks for the least common multiple. We already see that both have 24 as a multiple. That is the smallest number. That is the least common multiple. Find the least common multiple of 4 and 15 with prime factorization. So 4 is 2 times 2, or 2 squared. 15, 3 times 5. The prime factors of 4 and 15 are 2, 3, and 5. Multiply the greatest power of 2, 3, and 5, 60. 2 squared times 3 times 5 is 60. So the least common multiple of 4 and 15 is 60. So find the least common multiple of 6 and 14. Prime factorization. 6 is 3 times 2. 14 is 7 times 2. So we have 3 times 7 times 2. 7 times 3 is 21. Sorry, let me just get, there we go. 21 times 2, 42. The least common multiple is 42. Find the least common multiple of 18, 24, and 48. 18 is 2 times 3 squared. 24 is 2 cubed times 3. 48 is 2 to the 4th times 3. The least common multiple, 2/4 times 3 squared equals 144. Because you're using prime factorization, use the prime factors. Multiply the greatest power of 2, 3, and 5. So the greatest power of each of these, 2 squared, 3 to the 1, 5 to the 1. This one, the greatest power is 3 to the 1, 2 to the 1, 7 to the 1. We already have a 2 to the 1, so we don't use that one. For this one, the greatest power is 2 to the 4th, so we cross out these 2 to the 1 and 2 to the 3. 3 to the 2nd. Cross out that 3 to the 1 and that 3 to the 1. 2 to the 4th times 3 to the 2nd equals 144. So for 12, 20, and 45, 12 is 3 times 2 squared. 20 is 5 times 2 squared. 45 is 5 times 3 squared. Use the highest number. So we have 3 to the 2. Cross out this 3 to the 2. 2 squared. Don't use that 2 squared. 5 to the 1. Don't use that 5 to the 1. We then have 2 squared times 5 times 3 squared. Or 4 times 5 times 9. 36 times 5, 180. End of lesson 5-7. We're going to quickly go back and make sure that you understand why we use those numbers. So, with prime factorization, you multiply the greatest power. So, for this number, 4, the prime factorization is 2 squared. 15 is 3 times 5. In this case, the greatest power of 2, 3, and 5 are the only ones present. So you use all 3. 2 squared times 3 times 5. But in the next example, we have 6, which is 3 times 2, both prime factors. 14, which is 7 times 2. We have 2 2's. 2 to the 1 equals 2 to the 1. We're only using the greatest, so we just pick 1. So 3 times 2 to the 1 times 7. We do not use the same number twice. We use the greatest of that number. So for the next example, we have 2 times 3 to the squared, 2 cubed, or 2 to the 3, times 3 to the 1. We already have a 3 squared, so we know we are not going to use that 3. So we see that we have a 2 to the 3, so we know we're not going to use this first 2. We then have 2 to the 4th, which means we are not using 2 to the 3rd, and we have times 3. We've already got a 3 squared, so we're not using that 3 either. You then multiply the greatest of the numbers. 3 squared is greater than the 3 to the 1. 2 to the 4th is greater than 2 cubed and 2 to the 1. The same with this. We have 3 times 2 squared, 5 times 2 squared, 5 times 3 squared. Just pick one of the 5s, one of the 2 squared, and 3 squared is greater than 3 to the 1. So we multiply those numbers. End of lesson 5-7. Okay, compare fractions. Enrique and his younger brother both have had a math test last Friday. Enrique scored 48 points out of 60, and his brother scored 55 points out of 75. Who got the better score, Enrique or his brother? Method 1, rename using the least common denominator, then compare numerators. 48 over 60 is 48 times 5, 60 times 5. 240 out of 300. The least common denominator of 60 and 75 is 300. 55 times 4, 75 times 4, 220 out of 300. 240 out of 300 is greater than 220 out of 300. Therefore, 48 over 60 is greater than 55 out of 75. So Enrique did better. Write each fraction as a decimal, then compare the decimals. 48 out of 60 is 0.8. 55 out of 75 is 0.73. 0.8 is greater than 0.73, so 48 out of 60 is greater. Same answer, 2 different methods. During the hockey season, Kyle scored 14 goals out of 24 shots taken, and his teammate David scored 18 goals out of 30 shots taken. Who had the higher scoring percentage? Kyle had 14 out of 24. David had 18 out of 30. Either change these into decimals or change them to have the least common denominator. 24, 48. That will give us David had the better shooting. According to the Pet Food Manufacturers Association, 11 out of 25 people own large dogs, and 13 out of 50 people own medium dogs. Do more people own large or medium dogs? Well, 11 out of 25 and 13 out of 50. Write them as decimals. 11 out of 25 is 0.44. 13 out of 50 is 0.26. Since 0.44 is greater than 0.26, 11 out of 25 is greater than 13 out of 50. A greater fraction of people own large dogs than medium dogs. You also could have changed them to have the least common denominator. So 11 out of 25, 13 out of 50, least common denominator is going to be 100. The least common denominator is going to be 50. 11 out of 25, 13 out of 50. So multiply this by 2. We get 22 out of 50. And we keep 13 out of 50. So 11 out of 25 is still greater than 13 out of 50. A survey showed that 21 out of 50 people stated that summer is their favorite holiday. 13 out of 25 people stated that fall was their favorite holiday. Do more people prefer... 13 out of 25. Do more people prefer summer or fall? Well, 21 out of 50, 13 out of 25. The least common denominator will be 50. Multiply by 2. That gives us 21 out of 50, and 13 times 2 is 26 out of 50. So more people prefer fall. 13 out of 25 stated that fall was their favorite. 13 out of 25 becomes 26 out of 50. So 13 out of 25 is greater than 21 out of 50. Therefore, fall has more people who prefer it than summer. 7 out of 10, 0.6, and 72% from least to greatest. Write 7 out of 10 and 72% as decimals, and then compare all three decimals. 7 out of 10 is 0.7, 72% is 0.72. 0.6 is already a decimal. 0.6 is the smallest, followed by 0.7, followed by 0.72. Remember, 0.7 would then have a 0 after it. So 0.72 is slightly larger. So 0.6 is less than 7 over 10, less than 72%. That's all we have for right now. Performance yet. After an Academy Award will be given to me.
Oh, really? So, he only separated to two parts, right?
I don't know what he did. Yeah, I think he uploaded just 105 and said that was enough for today, and then tomorrow.